Hello and welcome to today's lesson. In this first tutorial, we will be able to identify multiplicities for polynomial functions, both algebraically and graphically. So we are in section 5.8 in our textbook. That's if you need to reference that in the book. We're talking about multiplicities and reading graphs. Multiplicity means when we have a polynomial that has more than one of the same roots or the same zeros. We're going to explore it graphically first. I'm going to draw a graph here. If you could copy yours down to look close to what mine looks like, that would be great. I'm going to change color here. We'll come up, and then we're going to do this thing, and then we'll do this, and then I'm going to wiggle a little bit through the x-axis like this, and then we're going to go right back up. So here's our polynomial function. We'll go ahead and call that f of x. How about that? This will be polynomial function f of x. It's important how our function is interacting on our x-axis. So I'm going to put some dots right here for where my real zeros are. So let's talk a little bit about multiplicities. I'm going to read this graph as I would from left to right, as always. And the first zero that I see is this one, but this is just the regular type. This is the way that we normally would cross the x-axis, like we know from before. There's just one zero right here. Nothing funny going on right here. But the second zero, this is one of our special cases. And it sort of looks like a little parabola right in here. This is when the graph is just tangent to the x-axis or bounces off the x-axis. This is a special type of multiplicity. This is an even multiplicity. This is an even multiplicity. What that means is there are at least two zeros right here. There could be 2, there could be 4, there could be 6, there could be 8, there could be 20, there could be any even number of zeros here, but there are at least 2. So this is what an even multiplicity would look like. That's why sometimes we call this a double root. But it could be any even number. So the next time is this guy. And this is another one of our special cases. And this is sort of like the cubic function, sort of the cubic right in here. And that's why this is going to be an odd multiplicity. This is an odd multiplicity. There are at least 3 zeros here. Now I understand that 1 is an odd number, but 1 looks just like this, just straight through the x-axis. When we do this sort of wiggle, and that's what I like to call it, a wiggle through the x-axis, there are going to be at least 3 zeros here. There could be 5, there could be 7, there could be 21. This is an odd multiplicity, and it looks like a little wiggle. And then we have this last one, but there's nothing funny going on here. That's like normal. There's just 1 0 right here. So this is a good graph to use to explore our different multiplicities. We have even multiplicities and we have odd multiplicities. What I'd like for you to do right now is pause the video and think to yourself, what do you think the degree of this polynomial function is? I'd like for you to pause the video and ask yourself, what is the degree of this polynomial function? Pause now. So when I pose this question at first, I get many responses that they think that the degree is 4. And I understand why they mean that, because they see 1, 2, 3, 4 x-intercepts. But the degree is not 4. The degree is 7. At least the minimum degree is 7. Now, where is 7 coming from? Well, we just talked about it. This is one of the zeros. And then all the way over here is another one of the zeros. So that's 2. There are at least 2 more right here. So that's 3 and 4. And there are at least 3 right here. So that's 5, 6, and 7. the minimum degree is 7 because here's 1, and then 2, 3, and then 4, 5, 6, and then 7. The minimum degree is 7. Now we don't actually know what the degree of this function is because we don't have an equation. And it would be nice to know what the equation is to know what the degree actually is. But the minimum degree has to be 7. Okay, and let's describe the end behavior. We've looked at end behavior before. That's what we use to describe both ends of our function. So we say as x approaches negative infinity, that's the far left end. F of x, that's what we named it. F of x will be doing something, our function. And the other side as x, or the other end, as x approaches positive infinity, that's our right end. Then our function f of x will also be doing something. This is how all end behaviors will begin. Now f of x might be g of x or h of x or even just a y. Just be careful what the name of the function is. But our end behavior will always start out as this. So let's see what's happening. On our far left end, as x approaches negative infinity, that's all the way down this x-axis, you can see that our function is pointing downward. So our function on the left side goes to negative infinity. And on the right end, as x approaches positive infinity, that's when we increase up the x-axis. You can see that our function is pointing upward to positive infinity. So that's where f of x is going. So that's a review of end behavior. So I would like to know a way to find the actual degree, not just the minimum degree. So let's look at our first example where we actually have an equation. So our first example is f of x. Now it's nice that f of x in this case is in factored form. If it's in factored form, then it's going to be pretty simple to find what my roots are or what my zeros are. So my zero from this first factor is a 2. I'm going to go ahead and list the zeros over here. You can call them roots. 2 is one of them because 2 minus 2 would be 0. So that's one of them. The second factor is x plus 3. So that must mean that the root would be negative 3. Now, because there are 2 of these factors, you can see that from the exponent here, this is a multiplicity, and it's a multiplicity of 2. I'm going to say mult of 2. We'll talk about that graphically in a minute. Let's get to our final factor. The final factor is x minus 5, so that means that the 0 or the root would be 5. But again, this has a multiplicity because we know that there are actually 3 of these factors. So this has a multiplicity of 3. I'll just say mult of 3. So we do know that this will cross the x-axis at 2, and I'm going to come all the way out here to 5. And at negative 3. I'll just go out here to negative 5. Just make some tick marks. I know that this will cross at 2, so I'm going to put a dot. I know that this crosses at negative 3, so I'm going to put a dot. And I know that it crosses at 5, so I'm going to put a dot. Now to sketch this graph, you could actually plug this right into y equals on your calculator and look at the graph. That would be fine. Or you could know a few things about the value of a. This first coefficient is a positive number. So I know that my graph is going to open up in a positive manner. So I know what the graph's going to look like, and I'm just going to go ahead and do that. What's interesting now is how it interacts with the x-axis. That's kind of what I'm interested in this tutorial. I know that at negative 3, there's a multiplicity of 2. That's an even multiplicity. So that means that as I'm coming down to this, I know that I'm going to bounce off the x-axis and go back up. Okay, now I know that I'm going to be coming over here to the 2, so let's see what happens there. Oh, this is just a regular 0. It's just going to cross right through. So at some point, this is going to have to turn back around, and then it's going to cross right through the 2. Okay, and then I'm coming over here to the 5. Let's see what happens with the 5. That's a multiplicity of 3. That's the odd multiplicity, and that's my little wiggle. So when I do that, I need to curve back up, and I'm going to wiggle through the x-axis like this. And I'm going to put my arrowheads, and there's my function. That's a sketch of my function. What's important is how we interact with the x-axis. My first question is describe what happens at each 0. I'm just going to go from left to right. At negative 3, we are just touching. You might say tangent. Some people might say bouncing off. It's the even multiplicity idea. The next 0 in order would be 2, and that's just crossing right through. It's just crossing right through. The last 0 from left to right is 5. I'm going to call this wiggling, for lack of a better word. It kind of wiggles through there. It might be tough for you to do at first, but it takes some practice. What is the degree? Well, we could count the degree from our graph. We've got 1, 2, 3, 4, 5, 6. We know that the degree is 6, or we could just look at it from the equation. There's one factor, and then 2 more factors, that makes 3, and then 3 more factors, that makes 6 total factors, so the degree would have to be 6. And finally, describing the end behavior. In this function, I know that both ends do the same thing. They both point up. So I'm going to write the end behavior as one statement. As x approaches positive or negative infinity, f of x goes up to infinity. You could write it as 2 separate statements if you wish. So there's our first example. Let's look at a second example. In this case, I've given you the graph. This is just a graph that I did on the calculator, and I'd like to do the same sort of things, answer these questions. It says state the roots and their multiplicities. So let's go over to the graph. I know that we cross, well, we don't really cross, but we touch the x-axis right here, and that is the first tick mark to the left, that's -1. And we also touch the x-axis right here at 2. So those must be my roots. Now what's happening at -1? That must have a multiplicity. You know what? I don't know that it's a multiplicity of 2, so I'm going to say an even multiplicity. Because I don't have the equation, I'm just going to say that it's even. And again, it's even because it's bouncing off the x-axis. The other root is at 2. And again, I don't know that there are 3. There could be 17 roots right in here. All I know is that since it's a wiggle type thing, that it's an odd multiplicity. Okay, when I'm answering the degree, I should probably say, what is the minimum degree? Because again, I don't have the equation, but I do know that there are at least 2 here, so that's 1, 2, and there are at least 3 here. So 1, 2, 3, 4, 5, that's the minimum degree, 5. And let's describe the end behavior. This time we do need 2 separate statements. As x approaches infinity, this is g of x, so I'm changing it to g of x does something. And as x approaches negative infinity, g of x does something as well. So let's see. As we go up the x-axis, my function is going upward. There's a little arrowhead up to positive infinity. And as we go to the left, down the x-axis, my function is going down to negative infinity. Thank you for watching this tutorial on multiplicities. See ya. Oh, thank you. You're too kind. Bye-bye.